All right. There's no one really here, but yeah, it's already dropping, isn't it? Holy shit. This is real bad. Oh, for fuck's sake. All right. So, disconnect protection is working. That's a good thing. We saw that. But my internet is not. It's super clear. Even like when I disconnected my router, I was on TikTok on 5G and it was so fucking slow. So, high chance I won't be able to do anything today. It's already dropping again. Less than before, but it is dropping. And I think that I might not be able to stream today. So, well, that sucks, but yeah. Think I'm not gonna be streaming today. Yeah, most likely. I mean, it seems to be working fine now. I'm not sure, but yeah. Um, I'm a little wary of even like trying to do something because if I do, it's gonna drop immediately. And yet it hasn't dropped in a bit, so maybe. Seems like since I saw that even my like 5G connection on my phone was lagging, there's a chance that this is just like a thing that's completely out of my reach. And there's not much I can do about it. Which it's been stable for the past like 2 minutes, but yeah. No, I'm not sure what to do here. So what languages am I using? I'm using C mostly. There's a little bit of C++. Yeah, C++. So today, most likely, none of them. I guess we'll see. Okay. I'm trying to stream again. We'll see how long it lasts. Because immediately the second I connected, it started dropping like crazy. So, not sure what to do. I don't know how much longer. If it drops even a little bit again, I'm just gonna end the stream. Because, yeah. This is clearly not working. And I've already tried everything I possibly could. Which is not a lot, but yeah, everything I possibly could. So, stream health. Oh, the stream is healthy. It's excellent. If you say so. All right. It's stayed pretty stable the last like 5 minutes. Um, but I can't trust it. That's the problem. It's healthy. It ate vegetables. Yeah, that's about right. Because it sure as fuck is not healthy in terms of like how it actually works. That much I can tell you. Okay. Let me snooze the ad a little bit longer because like the last thing I want is for people to just watch ads the entire time and then me being like, yeah, I'm not streaming today. Bye. Thank you for watching the ads. Made me a ton of money today. Like 10 cents. Good job. Thank you, everybody. Capitalism will be proud of you. Okay. So far, we're doing okay. So yeah, we're doing mostly okay. 10 cent. All right, maybe. Okay. Yeah, here's what we're gonna do. I'm gonna snooze one more time, which is gonna put the ad 10 minutes from now. If by the time I get to the ad, the stream stays stable, then I'm gonna try to stream. If not, I'll just try again tomorrow. But right now it seems to be working mostly fine. All right. Might as well like do something in the meantime. Okay. What was I talking about before? Yeah. So when it comes to the OS, virtual addressing support, we're getting there. Still got a lot of things to figure out. They're not super fun things to figure out, but I still got a lot of things to figure out. But it works with one process, but the second you try two, it will crash because they're overlapping each other. Because like I said before, the top level translation table is working. The lower level ones are not. I have a partial fix for that on my laptop, so it's not committed or anything, but it isn't working. I just realized I'm also mapping it twice. That's a little stupid. But in process loader, this is doing mapping and this is doing the exact same mapping. That's probably not right. I can at least undo that. That doesn't change the fact that it is overlapping, but whatever. Yeah, that doesn't work. You can have to. Oh, another thing that I added to the system. Okay. Seems. Oh, it dropped a little bit. It dropped a few more frames, but it's mostly doing okay now. Another thing that I noticed. Remove my page table in the frame buffer. Okay. About like focus. I made it so that the shadow only shows up on the window that is focused. If you disable shadows, sorry, but you don't get any visual indicator for the time being. But with the mouse, you can choose which window is focused. So I can now use this one, move, use this one. That's a pretty useful thing. And if you do it like this, you can have the same program running twice because it's using the same memory, so it's not a big deal. But yeah, I'm gonna have to fix that. And like I said, I was doing a fix for it, but then new pages that are allocated are not working. And I should have a fix for that, but it's not working. So I gotta debug that. This was happening at 3 a.m., so I didn't get a whole lot of a chance to look into what was happening. I was just like, you know what, let me go to sleep, figure it out tomorrow. And here we are. It's tomorrow. I haven't had time to figure it out, but yeah, I'm gonna have to do that either later today at 3 a.m. or tomorrow again. At least I'm not working tomorrow, so I should have more time for that. But yeah, I really want to get this MMU stuff done. Alright, I'm gonna push my changes. Hopefully this doesn't break the stream or something. Alright, that worked. It didn't destroy the stream entirely. That's pretty cool. Cool. Okay. Okay. So yeah, seems to be doing fine. We still got 6 minutes on the timer. If it drops again, I'm out. If not, we're good. Bro, why are you shaking? This damn dog. Hold on. Sorry. Alright, there. I put a blanket on him. I could literally hear the bed shaking when he was shaking. Um, he's also behind me, so you can't really see him, but yeah, there he is, wrapped in a blanket. He looks like the survivor in a horror movie at the end when they're given a blanket and they're like, "Don't worry, he's dead now." And then they go look for the body, and the body's not there. Sequel incoming. Okay. Dare I say it's working now? All scared to say that, but dare I say. Okay, what else? I don't even know what to work on today. So I was supposed to start a stream an hour ago, but didn't really work. So gonna have to figure that out again. Okay, but full virtual addressing is coming. It's almost here. It's almost here. Just a little bit lost. Actually, once I fixed the bug that I mentioned I found yesterday at 3 a.m. and haven't been able to look at since, technically it's gonna be there. Everything beyond that point is just improvements, like mapping the kernel entirely to the higher level. Maybe finding a way to make GDB work for it, but don't expect that. Let's face it, it's fucking GDB. Ugh. And yeah, things like those are gonna be useful to have, but technically it's gonna be working once I find the bug that I ran into yesterday. So pretty close to being done with it. If I had any time today, I would have been able to do it, but yeah, not really. Okay, what I'm not sure about is what to work on today, to be completely honest. Kind of unsure. First off, how long the stream is actually going to be able to last. Second, what to work on, what to actually work on. I have some possibilities. Okay, we have 3 minutes until the ad. If we get to it without any major connection issues, then I can believe that the stream is going to work. I'm going to run the ad, and after that, we're going to begin actually doing something. If not, we'll just leave it for tomorrow. And I'll keep working on virtual addressing in the meantime. All right. Yeah, what do I want to do? Okay. You have the possibility of designing a file system. Not super inspired to do that one, to be completely honest. I have the possibility of, well, this one's not really a possibility because this one relies on networking heavily. And first off, we already saw what the network is like today. Second, I don't have another device to test with, like a Raspberry Pi, for example. I mean, I do have my laptop, but like, yeah. Because I would want to do like a distributed file system using an IMP protocol or a custom protocol, because, yeah, I might want to do a custom protocol. But I don't think I'm quite there yet in terms of hardware for Raspberry Pi and in terms of stability of my network. Also, it just doesn't work with my network. So that's already a non-starter. The system does not connect to a network from this computer for whatever reason. Or the Linux computer, also for whatever reason. There's making the kernel modular. There's one thing that I didn't put in here at all, which I looked a little bit into last. Okay, no, I did put it, but I put it here. Dynamic loading. There's that, which I said I might work on today. Should I run a poll like I used to do? Maybe I'll do that during the. Okay, hold on. I'm gonna ask what we can work on today. There's 3 possibilities. No, don't start the ad yet. Holy shit. No. We gotta do this fast. Okay. Okay, number 1 is design a file system. Number 2 is dynamic loading of programs. And number 3 is unit testing framework. All right. 1 volt per IP address. Okay, there we have it. Here is the link. Did it not copy? Why did it not copy? Come on, we got 16 seconds. Bro, why is it not copying? Holy shit. Okay, there we go. And I'll be back after the ads and we'll know what to work on. All right, we're back. Kinda checking on the music.
All right, we're back.
All right, that's good. Okay, so my voice is actually louder than the music. Okay, I noticed a thing actually with my microphone earlier. So here's the results. Apparently we're designing a file system today. I don't know about implementing it, but we're designing a file system today. But I noticed something when I was recording my video that I posted last week. And it seems like my voice gets clipped all the time, especially when I make P sounds. Sorry if that was annoying. I probably shouldn't have done that. But yeah. That made it really difficult to film the video because I was sick for a long time after I recorded the voiceover for that video. So I had to like I couldn't really speak properly. And so I couldn't re-record the parts that were messed up. Tried to hide them as best I could. But yeah, the quality in that video is not the best. And I noticed that it also happens in my live streams. So Trying to fix that. But I think maybe now it's a little bit better. Now it's not as loud, especially if I make a P sound. If I make a P sound, it's not gonna pop as much as it popped before. Hopefully. I'll probably have to watch the VOD and figure it out. Okay. So designing a file system today. Focus on designing. Not gonna do a whole lot of coding, to be honest, today, most likely. Because, yeah, I want to decide what this file system is gonna look like before I do anything like that. And then, here's the painful part. I'm going to have to create a fucking... Holy shit, this one's gonna be painful, actually. Command line tool. I was just talking to someone literally before I started the stream about this stuff. But yeah, I'm gonna have to create a command line tool that has this file system available on it. But, oh well. I don't know when I'm actually gonna implement it, but yeah, there's that option. There's also dynamic loading. I genuinely did not understand what you even have to do when it comes to dynamic loading, but we don't have to do that today, so we're good. And actually, designing a file system might be good because, like I said, not gonna do a whole lot of code, and hopefully that's gonna make me able to at least like fix the issue that I'm having with the virtual addressing. Test it a little bit, put it in main, and start developing from that. So that's a possibility. But of course, we'll see. All right. So, cool. The file system. Does this work today? Nope. This always works though. This is all reliable, okay. Do you have a page for file systems? I think it was last stream, but last week anyway. Last weekend or Monday, I don't remember when exactly. We were looking at the different types of file systems. Ooh, turns out EXT, not XFAT, EXT, fucking shit. XFAT, I already knew that, fucking shit. FAT32, fucking shit. But the worst one of all is EXT. And all Unix-like file systems. They stink of Unix. You can smell it in the air. How did you get into OS stuff? Took a class in college, got interested in it. Never did anything until now. Kinda just winging it. That's mostly how. Okay, so I can't say that there is a single file system that I am even like remotely interested in taking inspiration from. Every single one I've seen is like, makes me want to cry. To the point, EXT though is the worst one. To the point that it made me think, holy shit, Microsoft may have been onto something. Do you know how bad you have to be for me to say that? You have to be real fucking bad. So, that leaves me in an awkward place because the most well-known file systems and the ones that I've worked on are something that I absolutely don't want to like ever deal with. Ever deal with. Ever. All right. So, there are a lot of file systems in this page, which it's actually one of the most complete pages that I've seen on the OS Dev Wiki. So that might be helpful. I'm assuming the information on here is from 1995, but I don't know. But char 1000 structure space defense. Fuck it. We roll our own. Actually, interesting. Uh, there are many kinds of file systems, from the well-known to the most obscure. Designing a unique one is a great challenge for any hobbyist OS developer. Yeah, I've taken on worse challenges. Like using someone else's file system, apparently. Many start by recreating fat-like file systems because it tends to be the first idea that comes to mind when thinking about how to organize files. While this approach is simple and familiar, there's real value in pushing beyond it. Rather than settling for another variation of what's already been done, this is an opportunity to explore new ideas, solve problems in original ways, and create something that truly fits the goal of your OS. Investigate all the possibilities before deciding to roll your own. Try to think beyond the common perception of how operating systems store files. If despite of this warning you decide to create your own file system, you know I am. You know, at this point I have decided that anything that has already been built, I'm not interested in. Because I'm going to have issues with it. So, fuck that. Then you should start implementing an FUSE or Fuse driver for it. Fuck no. Thank you. I'm not doing that. That's funny, but no. Okay, maybe. I mean, I don't know. That's funny, but no. First, okay, today we're focusing on designing. I don't know about implementing. I was literally having this conversation right before the stream started, so not about my file system, but still. Consider carefully what it will be used for. Storing files. It's a big one. I think. I'm not sure yet. It's all up in the air just now, but yeah. A boot sector. Yeah, sadly, my file system is going to have compatibility with multiple partitions, and it's going to have compatibility with FAT32. So that's not really like super difficult when it comes to designing the actual file system, more so to designing like whatever I use to create the file system. Like to actually create an image of it or to format an SD card with it. All of that I'm gonna have to figure out how to do. So that's great, right? Okay, use a program to figure out the layout like a spreadsheet. Oh, a spreadsheet is not a bad idea. Actually, I hadn't considered that. Thank you for the idea. Thank you for the idea. We'll take it. So yeah, we'll need a boot sector. We'll need a partition metadata. We'll need a file table, and we need the data area. Then we'll want to create a program to read and write disk images with your file system. Part of this will be portable into the file system driver, and it's strongly recommended to create a Fuse driver for your file system and implement the file system into your OS. Wait, Apple has NTFS? What? B-tree file system. It's a Linux file system with features such as copy on write and transparent compression. I saw that here, isn't it? No, I mean, I've heard of it, but it's not here in the list. Damn it. Oh, cool. I'm sure this page was actually available back in, 2000. Oh my god, 2003 when they wrote that page. Cool. Okay. There's like a hair that keeps bothering me. Do you have a list here? All right. Okay. So wait, hold on. What was the one? BTRFS. I'm not seeing it here at all. So yeah, they don't have a page on it. They do have an entire page on rolling your own file system. BTRFS is pretty new. Is it? Butterfs. ButterFS. Oh, ButterFS. Okay, I've heard of it. I've heard of it. But, oh my god, I cannot speak. I've heard of it. But okay, it's from 2007. That's not that new. Okay. The copy on write B tree was originally proposed by IBM researchers. 2007. Ricer FS first at the time joined Oracle. Alright, we don't care about this design. B plus trees, which are widely used as on-disk data structures for databases, could not efficiently allow copy on write based snapshots because its leaf nodes were linked together. If a leaf was copied on write, its siblings and parents would have to be as well. I'm already regretting this. What if I just don't have a file system at all? Because, yeah, who the fuck needs a file system? Why would you want the file system? Again, what if I just implement 9p for everything? We consider that. Okay, I gotta do this. Within each directory, directory entries appear as directory items whose least significant bits of the key values are a CRC32 C hash of their file name. Their data is a location key or the key of the inode item it points to. So we're still doing inodes. Alright, no, you know what? No, not reading that. Please note that rolling your own file system is not recommended. You're likely to make it a FAT style file system, and please, we don't need another one of those. Okay. It also says that you shouldn't do this fucking article, and yet here you fucking are. However, those of you who wish to defy convention, then we need to stop you making another fat for sanity's sake. So here's the tutorial on how to avoid fat. Alright, Ozempic? No? Oh, okay. So how do you avoid a fat? It comes down to recognizing a fat and punching yourself if your FS matches the description. So use trees and others, and don't use a file allocation table and others. So to not make a fat, you don't use a fat. FAT, fat. Great. What is this inode propaganda against fat? Is there genuinely no other way to do things besides those two ridiculous systems? Have we really not put 2 and 2 together? What's happening? Does anyone know any like CPU manufacturers that I can talk about? I can talk to in order to create just my own fucking everything? Just start truly from scratch. If anyone has any like contact emails or like anyone, please let me know. If I don't have to use existing hardware, I'm probably gonna be happier. I mean, maybe. Let me hit up my dad who works at AMD and Intel. Oh, don't fucking do that. No. No, it has to be a reduced instruction set, please. No, not those. All right. Okay, they're talking here about other like file systems. There are only five file systems that are both relatively easy to implement and worth to consider. There is no general recommendation as the choice depends largely on OS design and style. Instead, you can read the comparison and make your own educated decisions. I can at the very least look at what I'm interested in. Okay. USTAR, metadata and data sectors. Widely used. Utilities to create tar images are available for every mainstream OS and many minor ones. Support special files like devices and symlinks. Support Unix permissions. Yay, Unix! We love you! They include ext2. Oh, fuck's sake. I understand why you would add it here, but come on. Now, what's bad about it is it's not a file system in the common understanding of the term. Generally, read-only, was never designed for in-place modifications, no support for fragmentation, no standard partition type for it. Not actually the format used for RAM disks by things like Linux. That's CPIO, which I'm assuming is like C3PO's little brother or something. Then there's RAMFS, file system inside of RAM. Probably my first implementation of a file system is going to be that. High flexibility of implementation, fast, will allow you to test your file system API without having to rely on file system specifics. Highly recommended as a starter file system to avoid morphing your file system interface around a specific file system. Ideal to unpack a USTAR or CPIO initrd image into, and changes are obviously not persistent and only in memory to be wiped after a reboot. Okay. FAT. I don't think this is valid anymore. It's no longer patented, but whatever. Can be read and written by virtually all OSs. The standard for floppies. Yay, floppies! Relatively easy to implement. Yeah, okay. Fair. Part of it involving long file names and compatibility is patented by Microsoft. I don't think that's valid anymore. Same as floppies is not valid anymore, but hey, whatever. Between floppy, micro, and soft, kind of losing the plot of what we're talking about here. Large overhead, no support for large files over 4 gigs. They're not even talking about like FAT32, they're talking about FAT. They're just straight up talking about FAT. No support for Unix permissions? No! You don't have Unix permissions? No! But the perfect operating system was designed in 1969. We must abide by its teachings. What do you mean you don't have Unix permissions? Anyway, ext2 supports large files, supports Unix permissions. Thank you. Can be put on floppies? Fuck yeah. Fuck yeah. Can be read and written from Linux. Holy shit. Cannot be natively read and written from Windows. No. No. It was so perfect. Very large overhead. Oh no. Of these beginner file systems, this is the most complex. No shit. Congratulations, Linux. You've beaten Microsoft in complexity. Shame on you. Shame on you. FAT says large overhead and ext says very large overhead. That's how you know. Okay, then there's BMFs, which supports large files. Implementation available as a static library. Comes with a utility program for creating disk images on Linux and Windows. Comes with fuse bindings allowing it to be mounted on Linux systems. Contains source code documentation. Does not support fragmentation. No. Less control over the source code. No. Actually, that is a deal breaker. I want to implement the damn thing myself. And then there's ISO 9660, the defined standard for CDs. If you boot from a CD, then this is the way to go. If not, don't make it your first file system. I would boot from a CD, but actually I prefer booting from a... my camera keeps dropping. I prefer booting from a floppy disk. So, sorry about that one, but alas, you are too advanced for me. So, I hope with this one, I may be cancelled. I may go from 11,000 subscribers on YouTube to 0 within 1 hour because of this. Is my stream fucking dropping again? No, we're good. We're good. We're good. Stream doesn't want to hear your opinions. Yeah. All right. So, stream fucking broke again. But because I was going to say something so controversial that Twitch was like, whoa, 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 not on my platform, bro. I don't want to get in trouble with the fucking CIA. I can already hear, if you listen very, very carefully, you can hear Linus Torvalds already, like cracking his knuckles, sitting down at his keyboard, ready to type out a fucking rant. However, here goes. Taking off my headphones so I can run away from you faster in case you people start chasing me with pitchforks. I am not interested in doing Unix permissions. You're not gonna do anything? You're not gonna kill me? Maybe you didn't hear me. I'm not gonna do Unix permissions. Are we good? Is that okay? Is chat accepting of my lifestyle? Okay. No? Okay, how do I ban you? Hold on. It's just one person saying no, so I'm just gonna ban you. It's gonna make it easier. No, I'm kidding. Make better permissions. Here's the permission. You want to use it? You use it. You don't want to use it? You don't use it. I don't give a shit. Fuck security. Here's these permissions. Why? Why? Now, here's the actual thing. I am not interested in building anything that I don't need. So, my first time adding a embrace the Temple OS model. If I didn't do networking, I would. And the worst part is I did networking because my YouTube, I ran a YouTube poll and people wanted me to do networking. I didn't even want to do it. But hey, it's like my second most successful video on YouTube, so I'm not about to complain about it. Also, I want to do a distributed file system. I feel like you need networking for that one. At least local networking for that one. But yeah, the plan is I'm not interested in implementing anything besides the most minimal implementation until I need to implement something more, at which point I will. So, permissions, I hardly know her. That doesn't work. But, yeah. How does a forgiveness system look like? I just got your joke. Forgiveness, it just released a statement. Like, unfortunately, on the 14th of November 2025 at 8:06 p.m. UTC, we suffered a data breach, and it could have very easily been fixed if our system had been written in Rust with like type safety, and if they had bothered with fucking file system permissions. But the idiot who built the system didn't bother, so whoopsie. Sorry, your data got stolen. Your ID got stolen. You may be thinking, you never uploaded your ID. Sure, you didn't, but we did for you. So, whoopsie. Anyway, sucks to be you, I guess. I forgave the person that deleted your data. Sorry, Dave. Um, my original plan for the file system was that you have very restricted access to it from within an application. The kernel can do whatever the fuck it wants, and an application has very restricted access to it. It is given like its own subset of the file system, and within that, it can do whatever it wants, but it isn't the real file system. But even then, you have to be careful to a certain extent, because like, do you want an application to like delete its own executable? That's a possibility. If you do something like that, I don't know. Embrace user only OS. That's a new one. I've heard of kernel only, but I've never heard of user only. Discord support had a data leak before a lot of IDs and other information got leaked. I think it was Zendesk. Rebel against the kernel. Giving 100 OS bugs to corrupt kernel to ease the way. All right, so we're not interested in permissions until we need permissions. We're not interested in even like fucking timestamps. I don't care about timestamps until I need timestamps. And I don't need timestamps. So literally my entire I've been able to work with a file system without timestamps or permissions this entire time, and I plan on keeping it this way for as long as possible. And if I do need permissions, I will implement them in the year 2025, not 1969. Thank you very much for that one. Unfortunately, that makes me not POSIX compliant. I'm a rebel. I'm a rebel like that. I'm a bad boy like that. I'm not compliant. I don't need your compliance to fucking POSIX. Okay. Well. What is the one that I read about here? That I was... Okay, there was this one, Ustar. I don't know what it was, but it's like a very simple one. And then bumps. OS Forum's gonna blacklist you now. They already did. Did you see me like trying to Google something the other day? Watch. Literally just by opening the page, I'm already rate limited. Just by opening the damn page. That's all I did. And I'm already rate limited. And yeah. So oh no, I'm gonna be blacklisted off of that. Oh no. Okay. We got Ustart. Is the POSIX standard form of tar, Unix's tape archive format. Unix is back! Fuck yeah. And tape archive format. Hell yeah. The 1960s are back, everybody. What were the 60s like? Should I dress like a hippie? Actually, that being the 1960s might explain Unix a lot. There might have been a certain amount of illicit substances involved in the creation of Unix that would probably explain a lot of what's going on in Unix. Now, as to why we've kept dragging it behind us for 50 years, I don't know about that one. Not much I can say about that one, but yeah. Okay. Each file and directory has 512 bytes sector containing metadata. If the file is not empty, then the metadata sector is followed by data sectors with the content rounded up to 512 bytes. What was the first OS? I wonder actually, what was the first OS? There's probably gonna be like a lot of discussion over what actually constitutes an OS. Because at some point we went from directly programming computers to making operating systems for them. And when exactly that switch happened? Transistor, mainframe, professional operators. Mainframe still had rudimentary operating systems such as the Fortran monitor system and IBSYS. In the 1960s, IBM introduced the first series of intercompatible computers, System 360. Oh yeah, that might have been the first one. Yeah. And they all ran OS 360, which consisted of millions of lines of assembly language that had thousands of bugs. Fuck yeah. Okay, so wait, hold on. The timeline is a lot different than I expected it to be. So you're telling me that it was in the 1960s that the first operating system was created, first official operating system, so to speak, was in 1966. And 3 years later, Bell Labs was like, let's make our own. Let's call it Unix. And in the year 2025, we are still relying, like building entire operating systems with the same philosophy that like the third ever fucking operating system was built with. I thought at least we would have like 10 years of knowledge before Unix was started. Granted, this one probably wasn't started in 1966. Most likely it was 55 or 65 or 64 even. I don't know. But yeah, like Unix is 3 years younger than the oldest operating system. Motherfucker. That explains a lot. And yet, it makes it like harder to understand why we're still relying on Unix so much. Why? Why? I just don't believe asynchronous programming was born just to let two people use an IBM mainframe at the same time. What else would you possibly use asynchronous programming for? There's one use case ever. That's the entire point of it. Announced in 1964. So if they announced it, they probably started it a little bit earlier than that. But Unix was started in 1969. And I don't know exactly when it was released. I think it was 71, 72. But yeah. We're still talking about... Holy shit, that is so sad. The operating system on which all others are built upon is fucking... It's like the second one ever built. Bro, come on. No, not really. Because IBM had more. Let's see. 84. Okay, so actually no. Unix was already there by that point. Cool. Anyway. Disappointed in the entire community at this point. Disappointed in computer science. I'm fucking done. I'm starting over. You know what? Redacted OS is not even an operating system anymore. It is now an operative system, like I called it in my first video. Fuck it. I've decided. I'm starting over. Computer science is done. Today's the end of it. We're starting a new one today. We're doing what do we call it instead of computer? Clanker science. Okay, now let's think about it a little bit more. Maybe not clanker science. Is this file system just a linked list? I think it's just a linked list. I have a feeling it is. Each file has a file name, 100 characters it looks like, which is more than like FAT32 can support. A file mode, owner numeric user ID, groups numeric user ID, file size in bytes, last modification time in numeric Unix time format, checksum, type flag, name of linked file, ustar indicator, ustar version, owner, group, device, miner, file name. Cool. Interesting. So no, it's not linked. It's sequential. Mm-hmm. Okay. Sure. BMFS was a file system initially designed by Ian Seiler for the Bare Metal OS project. Since then, it has been put into a separate project and developed and continued from there. Its initial design, it supported only a root directory with a maximum of 64 files. Fucking love it already. Why else would you need anything other than that? The perfect file system has already been created. If you have more than 64 files, you probably just need to start over, bro. You're done. The idea was to have a simple file system that supported just enough of a file system for a database program to use. The development continued and the design changed a bit, and now it supports subdirectories. God damn it. They already overcomplicated it. File permissions. They complicated it too much. User and group IDs and more. It also comes with a user space program to construct file systems and examine their contents, and a fuse binding to use BMFS on Linux systems. It is constantly being improved. I figured. This is how to use their API. Nothing on their design. Let me see about Wikipedia, maybe. I don't think Wikipedia knows about it. Unless it stands for the Black Mafia family. I don't know what the S stands for, but yeah. Families. Probably. There is also Blowing Money Fast, the second single from Rick Ross's fourth studio album. I don't think that's what I was talking about. Right, how are we doing on connection? Seems to be doing okay. Don't trust it, but it seems to be doing okay. Okay. Oh. Little FS, the emphasis is on little? Ooh, fucking yap on this shit. Okay, let me read it. Even a Raspberry Pi Pico, not micro, has multiple cores. Networking and file systems, just like desktop computers, sort of. If the file is small, that's not a huge problem, but if with a 10 megabyte file, it takes forever. Yeah, I feel like this one is for embedded. I just want to see what they used to build it. If not, you know what, we are just go with a fucking... do I have like sheets on this thing? I don't. Surprisingly, actually. Let me see if I'm logged in. I am. Wait, because the program is not called, like I don't have it installed, but it's called numbers, not sheets. The idea of using a spreadsheet for this looks pretty cool. Intent for ESP Arduino types, that makes sense. Does it have anything on the design of it? Because I didn't see anything like that. Oh wait, okay, because that's not an implementation of little fs. Failsafe file system designed for microcontrollers, power loss reliance, dynamic whirl leveling, and bounded RAM and ROM. Well, we're not interested in such fancy features. We just want to design that. Ooh. At a high level, LittleFS is a block-based file system that uses small logs to store metadata and larger copy on write structures to store file data. In LittleFS, these ingredients form a sort of two-layered cake, with the small logs providing fast updates to metadata anywhere on storage, while the cow structures store file data compactly and without any wear amplification cost. Both of these data structures are built out of blocks, which are fed by a common block allocator. Is there anything that's stopping me from just designing this thing like I would any data structure? I wonder. Seriously. This is the default spreadsheet? No, what the fuck is this? That's the basic blank one? No, it isn't. How is that blank? Oh, apparently it is. Alright, well. If I had to design a file system without looking at any reference, which is usually how I design my things, not looking at any reference, how would I do it? Here's what I would do. I would have a header at the very beginning because I need a header. I need some global place that you start with. And okay, so this is going to be a sector and these are going to be entries. So yeah, we have a header. Maybe it uses like a identifier here for the header, so that you look at this and you're like, okay, I'm looking at the right place. Then I don't know, the total size, in case we need that information. And let's start with a root pointer. The root starts here. It's a directory, so it has a name. Let's say that the name takes up like this much. Just one, yeah, whatever. And then well, no, the root doesn't have a name. What the fuck are you talking about? No. Okay. So you start at sector like 2. I'm basing it off of this number, really. Let me organize this a little better. Okay. So at the beginning of our disk, we have our header. It has a size that tells you how big the disk is. And it tells you like where the root is. It tells you that the root is in sector 3. So you go here and this is the root. And inside of it is going to have a bunch of directories. Like for example, I don't know, red OS and red OS and util. Don't know why that was so difficult to type, but whatever. So then red OS is a folder which has like startup.wav and it has like desktop.png and it has like user folder. This spreadsheet software is really weird. Then inside of util, there's going to be, I don't know, bin. And inside of bin, there's going to be a cat. And inside of cat, it has all that. Not sure that this makes a whole lot of sense, but no, I think it does. This is like Apple's spreadsheet software. It's called Numbers. They really thought about it a lot and eventually came up with that name. All right, so whenever I type random numbers, that's just like data. Okay. So I could just do entries like this. I may just fill it in. Startup.wav is at 11. Desktop is at 12. User is at 13. Bin is at 9. 9 is 10. Cat, that's it, that's it, that's it. And user points to demo, which is at 14. Okay. So I want to get like /root / well, there's not really /root. It's just /redOS user demo.elf. Although I called it just demo, so that. What do? I start at the top of the directory. It has a header. It points me somewhere. It tells me to go to sector 3. I go to sector 3. I find the root. It tells me the name of a file, which matches what I'm looking for. So I follow its pointer, 5. Takes me here. I find startup.wav. That's not what I'm looking for. I look at the next one. Desktop.png. That's not what I'm looking for. I look at the next one. User. That's the one I'm looking for. So I go to 13. Takes me to demo. That's what I'm looking for. I follow its pointer and I find its data. Is OS Dev popular now because of Twitter? Why Twitter? Okay. Overall, seems like a simple way to structure a system. However, of course, we got to consider some other things. Like, for example, what happens if you have too many entries? Let's say that I only allow 2 entries for a sector. So as redOS right now has 3 entries inside of it. That's too many. So what I could do is simply tell you first entry, second entry, and then a pointer to the next one, which is going to point to 15. This is going to be a continuation. How many bytes does a pointer have on a 64-bit system instead? I don't know. Seriously? Is it vibe coded? It's vibe coded. Why the fuck am I even asking? 13. All right, here we go. So that's how I handle a file system being, or a folder being too big. I start at the root, points me to 3. I find red OS, go here, boom. Start.wav, that's not the one I'm looking for. Desktop.png, that's not the one I'm looking for. I've already followed too many. There's only 2 entries that I can possibly look at. So I go to the next pointer, points me to 15. I continue from here. I look at this one, and then follow this one. But that's not a thing. So I go to user, 13. That's it. I found it. And then again, go to 13, take me here, 14, takes me here, found the data. Cool. What if a file is deleted? I'm not gonna lie, what I'm doing right now is based off of fat. But fat, instead of having a pointer at the end, is going to have a fat allocation, a file allocation table. I believe that's what the F stands for. It's allocation table. I think it's file allocation table, where essentially you just follow it in a chain until you reach. It tells you all the sectors that you have to look at to reach the full file, which is a little bit shitty, but whatever. How was the first OS made without having an OS? Well, you didn't really need it. It was like custom programmed for whatever it was needed to do. Really, the OS is just to make it a little bit like more generic. Also in assembly. Apparently it was like, what, millions of lines of assembly? Do I still have it open? Is this the original? Yeah. Maybe it said it here. Millions of lines of assembly language and had thousands of bugs. Okay, so if I had to design a fucking file system, this is how I would design it. You know. I feel like FAT had the right idea with design, except for the file allocation table itself. But in terms of the like somewhat simple tree structure that it has, I feel like this makes sense. But okay, what I said before was, what if the file is deleted? And let's say that this one is deleted. Let's call it just deleted. Right? If I find one that's deleted, I just skip it. Go directly to the next one. I read this one, this one, this one. And I can even put like a stop. So in a way, what I'm building is just FAT32 without a fat allocation table. They had a point when they said try not to build a fat file system, and that's exactly what I'm doing. Then again, I don't see the problem. You know what? I'm not taking the opinions of dead people. They're probably not dead, but they wrote that in like 2003 and they don't even remember that they wrote it, so. RFAT. I'm gonna call it Ozempic. You know I gotta call it Ozempic. I obviously cannot fucking do that. That's a trademark. But let's not pretend I didn't have a gaming channel where I called a Sims character Ozempia. So that was a thing. What's preventing me from doing this? Besides the fact that that was a fucking YouTube channel and this is a like actual file system implementation. All right. We can just call it thin. Or maybe call it just like skinny fat. It doesn't actually have a file allocation table. So instead it just uses a pointer at the end. That's it. Okay. Well, I feel like philosophy wise, that's how I want to design it. And then, the actual logic of designing it like this might not be the smartest idea, but it might work. And definitely the first version of it is going to be just like RAM FS. I'm not doing fuse drivers. I'm not doing that shit. I'm not doing that. I'm not doing that. Okay. Eventually, but not. If I find a way to actually do like a command line tool that builds an image with this file system, then I'm done. Oh, one thing that I am kind of like ignoring, I'll talk about after the ad because there's an ad coming up. So I'll be back in 3 minutes. We're back with the skinny fat. It doesn't just mean Jester. I mean the provisional name that I have given to this file system is skinny fat. I'm not keeping it. I'm just gonna call it skinny. And instead of an index, it's going to use a legend. So it's a skinny legend. I don't know. It's the best I could come up with on a short notice. Okay. Stream seems to be stable. Ish. Seems to be mostly stable. How you doing, Jester? Why are you behind me? Why don't you get over here? Like, he's very hidden. I need him for engagement purposes. So I'm just gonna sit like this from now on. I'm just gonna tilt my keyboard and work like this. Cool. But then it even highlights even more just the empty space that's over here. So maybe I'll just move over here instead. Just like, no, but it covers him. Too bad. Sorry, Jester, you just won't be on the stream today. Okay. I couldn't be bothered coming up with anything better than fucking fat. What if I make my file system a binary tree? You can only have 2 entries per folder. Has anyone considered that? Maybe you don't need to have multiple files per folder. You can just have a fucking binary tree. Just left or right. You just represent file paths as 0s and 1s. Couldn't be easier than that. Couldn't be simpler. Absolutely no reason to overcomplicate things more than that. If you overcomplicate things more than that, you fucked up. All you need is 16 bytes for 2 different pointers. Did I just reinvent computer science? Am I getting a Nobel Peace Prize? Because I couldn't think of a better one. Am I making the new Unix here? I think Dennis Ritchie is on his way with a medal right now. Is that his name? No, not Denise Richards. Dennis Ritchie. Ritchie with a T. This dude is on his way to my house right now. Linus Torvalds is coming after you. He's got a sniper rifle. He's assembling the sniper rifle right now. If you see like a red line, a red dot on my forehead, it's been nice knowing you. Unfortunately, I will not be able to continue my project. The CIA, led by Linus Torvalds, is coming after me. It's been nice. But I will be spending the rest of my days in a CIA black site in Finland. I think he's from Finland. Yeah. Wait, his name is Benedict. Holy shit, he's the chosen one. I can't compete against him. He's too strong, he's too powerful. And he was, hold on, he was born in 1969. The same year that Unix was created. They were born on the same year. This was fucking... It was an honor too. It was fucking meant to be. He's the chosen one. Not Terry Davis. It's always been Linus. I feel like I already knew that. I already found out on stream, but I have short-term memory, so I'm finding out again. Yeah, he's the one the prophecy told us about. Personal life. He's married to a 6-time Finnish national karate champion. Okay, he's not even pulling out the fucking sniper rifle. They're just gonna melee me to death. Jesus Christ. It's gonna look like Street Fighter over here, and then it's gonna be over. He was running introductory computer laboratory exercises for students and instructed the course attendees to send him an email as a test, to which Tove responded with an email asking for a date. Damn. Damn. It's, what year was it? 1993? Why do I feel like it might have been like one of the first instances of e-dating ever? Yeah, he's the one that the prophecy told us about. There's no competing against this guy. You know what? Fuck it. RM. We're done. It's over. I can't fucking compete. I've tried, but he's just too powerful. All right. So we found out that yes, he is coming from Finland, but he is not in fact coming with a sniper rifle. He's just gonna like do hand-to-hand combat here. Except I won't even have like enough time to react before I'm destroyed entirely. So yeah, not even the CIA. He can solo me. All right. Well, unfortunately, I've created a skinny file system. It's been nice knowing you, Jester. I loved having you as a dog. You've been great. Take care of yourself, okay? Don't eat my corpse. If there's even anything left to eat afterwards. I feel like he's just gonna obliterate me to the point that I no longer exist. Well, we have designed a file system. I'm not convinced, to be honest. I feel like it could be made even simpler. But what's simpler than a literal tree structure? Like, I feel like we're good. Hell, for that matter, the header is technically not even needed. Okay, nah, I'm fine with wasting like what 512 bytes on a fucking header. That's fine. No, not even 512 bytes. Probably gonna use like fewer. Well, it's useful to have 512. I don't know. Just like using a whole sector for the header makes sense. Because you're not gonna put data in the same sector as the header. But what am I gonna use 512 bytes for? Should I just put like a million booleans in there? Here's a file system design. Essentially, the way that it works is in the header, the 512 bytes, or actually however many bytes it takes to do this, each bit inside those bytes represents whether or not there is a entry with a specific file name put sequentially. So it goes like this. Is there a file called A? No. Is there one called B? No. Is there one called C? No. So on, and eventually we get to like AA. No. AB. No. So on. Eventually we get to like user.elf. And then we put a 1. How's that for a file system? So you just have to like hash the name of the file that you're looking for and then check the bit corresponding to that file. I wish I could go travel back in time and tell the Unix people that this is how they should have built their file system, because it would have been great. It would have been absolutely amazing. Unfortunately, they were self-sabotaging, and instead they went for inodes. Is this based off of the Linux kernel or no? No. Dios me libre. It is not. It's completely from scratch. Although Twitter says that it's not from scratch because I used a compiler. Skill issue on my end, apparently. I'm sorry. But yeah, according to my definition, it is from scratch. Okay. if this is what I want it to look like, then what information do I need? Built from binary? I don't know. It feels a little bit like cheating, you know? Like that's so... I feel like I should just like expand my consciousness to the level that like I can directly communicate with computers and tell them what to do. And literally no OS is from scratch. I don't know. It was just like I mentioned last week that somebody like tweeted a video of mine, and I was looking at the replies, and most people were like, "Oh, I've been following for a while. It's interesting." Or like, "Oh, wow, so cool." Um, and then this one guy was just like, technically he used the tool chain, so it's not from scratch. Yeah. Uh, you can already guess how much that person paid for Twitter. It's hint, not zero. Probably, I don't remember. But that feels like a blue check mark type of response. So yeah, unfortunately, my OS is not from scratch. I have been lying to you. I called my channel developed from scratch, but I am a disgrace. I am unworthy of the title of um, Linus Torvalds murder victim and Labubu copyright strike victim. So unfortunately, I have lied to you. Also, it wasn't a copyright strike. It was a copyright claim. See, I cannot stop lying. I'm literally a pathological liar at this point. All right. How about I actually get some work done today? Although, to be fair, the point was to design a file system. File system is designed. Look at it. Yeah, there you go. Got some mock-ups for you. But yeah, maybe I need to consider like a few things, such as the name of the files needs to be limited to a certain character count. I am not interested in long file names. Screw that. However, I am interested in one thing: forwards compatibility. Because this is a thing that you're going to need. So I am just going to put an extended field, which is going to be reserved at the beginning. And anything that's needed is going to be put in there. In, you know, future versions of the OS. In the future versions of the file system, not the OS. Okay, cool. So what do I need to build this file system, which will be called... I don't want to call it Skinny FS. Yeah, whatever. I'm calling it Skinny FS. I'm also like working off of the wrong branch. So I gotta switch real quick. All right, Skinny FS in the file system. I'm not actually implementing it today, because I actually haven't had dinner. So stream is not gonna go for like a million more hours. Even though because I wasted an hour in network issues, I wasn't able to stream for like a ton of time, but yeah, a bit of a shorter stream today, but we have all of tomorrow and all of Sunday to actually implement this stuff. And maybe actually after dinner I'll be able to do some virtual address stuff, and then I'll be able to work a little bit more on Mr. Skinny tomorrow. But You know what? Skinny header is a little bit too close to skinhead for my liking. I don't know what to call it. Effaboo and Galinda, or whatever the fuck their names are. I probably should just replace the word header with something else, or just not think that it's too similar to skinhead when it literally is a completely different word, but whatever. I also don't like the name skinny for it. It's just stupid. But it is going to have a pointer to the root sector. And it is going to have a checksum. Let's give it a checksum, or like a signature. 8-bit signature. Well, actually, let's make the signature like a character. 8 characters for a signature. And that's 16 bytes out of 512. I hope that's the right number. Let's see. 496. And then 4, that's 504. And then another 8, that's 512. Yeah. So that's going to be the header for my file system. It is going to be a signature, a pointer to the root sector, and 496 reserved bytes. Because I don't know what else to put in there. Like I said, I might even skip the header entirely. I shouldn't, but I could if I wanted to. Okay, no, actually, another thing that I do need is a version number. Which should be written in the same format that I wrote my version numbers for, like, the drivers, which is 64-bit. And then this one loses another, becomes 488. And then I guess there's a reason they're reserved. I guess version 0.0.2 is going to have a little bit more than this. Then we have to define an entry. SkinnyFS entry. Which an entry is going to have a pointer. It's going to have a size, and the size is, I believe, provided by who, bitch? That's 8 bytes and 8 bytes each, 16 bytes. And then wait, no. Never mind, there's gotta be more entries, not just one entry per sector. I did that wrong. 496 is a little bit too much. Okay, what's a good file name number maximum? Um, 64? 1024, so that's 2 sectors just for the name. So not even including the entry pointer and size. I'm gonna go with 64. Wait. The entire entry is going to be 64. Which means we need to take 16 out of that, so 48. Yeah, you know what? A sector being, yeah, I'm basing it off of sectors, but not so sure about it. I don't know. Where can I look at like file names that I have, for example, for the Raspberry Pi? Can I see their like length? This one seems like the longest. And it has 20 something characters. It's not really the longest. But what can I type in? I don't know. I'm gonna call it like Hello World Game version 2.3.4 build 345 slot 1 2025 11 14 22 well 2104. How many is that? Dot save. That's exactly 48 characters. But, you know, a file needs slightly more than just these 2 entries. I already defined that it needs attributes like deleted, last, and some reserved stuff. Where would the path be? You build the path by traversing it. Like I showed before with root, red OS, user, demo. Kind of like that. Okay, let's make it 128. It's a little bit silly to make the character names so. How about one sector with data? Where the name is only length? I feel like that still limits the number of names, so not a whole lot of the difference. Okay. I feel like I want this whole thing to fit inside of 128. So that would be 8, 16, 24, 25. And that leaves us with 103. Or we make this 100. We make these 11 reserved. So we can fit 4 of these entries inside one single sector. and then a pointer to the next one. Or ideally, you do it in more than just one sector at a time, because disks are usually optimized to read sequentially. So you might want to have slightly bigger sectors, say 1024 or 2048. And then you could have a bunch more entries. Did I do the math right on this? Who knows? $128. That part is right. Since you can't have asserts, 512. See, I'm already starting to use some of the reserved. So you want to read in sectors. All right, so essentially you start by checking the signature of it. You wanna go to, well, no, first off, you wanna look at the version, because the version will tell you what to do with these reserved things. But ignoring that part, you'll want to go to the sectors per chunk. That will tell you how much data you're gonna want to read. Instead of reading one sector, which is 512 bytes at a time, you read multiple sectors at a time. Say, for example, that it tells you to read 4 sectors at a time. That's 2048 bytes of data. Then you go to the root chunk, you read 4 sectors, and in those 4 sectors, you will find entries. And those entries are going to point you to okay, I'm starting to come up with another issue that there is, but we'll get to that one. The entries will have 100 characters of a name. You will check against it to see that it's the one that you're looking for. If so, you are going to check its entry pointer. And its size will tell you how much you have to read. But a file may not, in the same way that a file system entry, in this case it only has like 2 entries. So it's a very restricted one. But the last entry in it has a pointer to where the file, the folder continues. Continues here, has this other entry, and then it's last, so you don't continue after this point. But for the there should be some kind of like, how do I call it? Header. Yeah, this is where it gets a little bit complicated. Because when I'm reading a file, I need to specify where that file like continues. Because for example, let's say that the startup.wave like has all this data. but then it continues here. I need to have a pointer to this somewhere. That's where the fat allocation table comes in. That's where FAT32 is pretty smart in that aspect. But well, smart, because the fat allocation table itself is actual shit. But one thing I could do is just put a very quick pointer at the beginning here that just points you directly to where the next entry is, or here, or maybe here. Easy, yeah, sure, but that means that you have to read 504 bytes of data, then go to the last 8, which point you somewhere else. There you're going to read 504 more bytes of data, then go to the last one, which points you somewhere else. Having 504 bytes of data is a little bit of a shitty number right there. So that part kind of sucks. And wouldn't know what else to do about it. That isn't like super wasteful. Number of sectors in the current chain. Next 8 bytes, chain pointer followed by data. Yeah, that's possible. That's possible. I can put it at the end. No, we already know the size. Like when you tell me to go to this sector for root, I already know to read exactly. No, this is actually like not structured properly, but I'm not gonna move it right now. I know how much to read exactly, and I know how to do it and all that, but it's not great. Linked list of sector chains. That's kind of what I'm thinking, yeah. I'm just putting it here. The problem is then you're not left with 512 bytes of data. You're taking up a little bit of data from the file to put it in the like to put like file system data on it. That part kind of sucks. And we already have the file size, so you don't even have to store that. You can do some cleverish math to figure that out. I like my hair more when I have this up, so I'm gonna put it up even though I'm not listening to anything. In the header of the chunks. So like here at the beginning of the file is kind of where that would end up. I mean, it's not difficult. You can just make it so that a file it could be something like this. The part that I hate about it is simply the fact that you will read 504 bytes of data. So I feel like if you read 512 bytes of data, that's probably easy to optimize, whereas reading 504 bytes of data is not. And probably the best thing you can do is reduce that down to 256 or something, I don't know. The first header in the beginning of the file is fragmented, also linked to the next chunk. That chunk will also start with a header. Yeah, I just hate the fact that my files would have to start with their own like file system header. That's the only part that I want to skip. But of course, I don't want to do a file allocation table because that's kind of equally stupid. Which is essentially just doing that chain outside of the file itself and into a reserved area of memory, which is not what I want to do either. You have 2 pointers per file. One for data chains. Yeah, but that would be 496. The point is, if I want to reduce it, I want to reduce it as much as possible. In skinny FS entry? Oh. Okay, yeah, I was thinking about that. Okay, so hold on. A file entry is now this, okay. And then like a next data pointer. So it's going to be a linked list of skinny FS entries. Which is kind of a waste of this. It's not a bad idea. It's better than put it directly in the file. That's 32 kilobytes, holy shit. Well, not necessarily, but yeah. Hold on, let me do some math. 512 times 4 times 64. It wouldn't even necessarily be needed. Or, yeah, okay, hold on. If I reduce this reserved, take 11 from here and 5 from here, that leaves us at 95. I make this a uint pointer to the list pointer, and then a And maybe something like this. Hold on. What if I do it like this? All right. And if I'm not mistaken, that would be 512. It is. Good. Okay. So an entry would point you to just one place. If it's bigger than 512, then you also look at the list pointer. This one will contain a list of other pointers to look at, 63. And if it's still bigger than that, each of which are going to be 512. If it's still bigger than that, then you look at the next list of skinny chunk list. And you read that. I feel like that could work. Not the most elegant, but it could work. And if you need some extra information, you take it from here. Yeah, that might work. That might work. Okay, so a file is 512 bytes or less. You just go here, you read it, that's it. It's more than that. You go here, you read the first part of it. You keep track of the size. Pointer plus length array. You already have the length here. It's pretty easy to do the math. Like, let's say that the size is, I don't know, this thing. Right. So I go here and I read the size. You know what? Let me simplify the numbers just a little bit. 6,000, and let's say that the sector size is 500 instead of 512 because I don't want to do like binary math like that. But okay. I go here, I read the first 500 bytes. So that leaves me at 550. I go to this list, which will contain, let's say I read enough that I only have 500 left. I go to here, it takes me to another entry. I read one more entry off of the chunk list, and that's it. So you already have the size here. That size tells you how many entries it has in total, and then you know how many entries to read here. This plus 1. Plus whatever you find here. Also 63 is... $512 minus 8 divided by 8. And the entry size stays the same, and this has to be one sector, so yeah. and then playing with chunks, then you have an easier way to work with it. Okay. I think this makes sense, essentially. I go here, takes me to a bunch of these entries. Oh, the same thing needs to happen for the directory. Because when it comes to directories, I actually built it planning for 8 bytes at the end. Or the last entry, not the last entry being a pointer entry, where you care about the entry pointer being pointing you to the next point. I don't feel like that makes sense when I explained it, but yeah. Essentially, I go to the root chunk. It points me to a bunch of these in an array. A fixed number based on the sectors per chunk. I read them, I check their names. If they match what I'm looking for, then I follow them. If not, I keep going through them. If I reach one that has attribute, say, like pointer 1, then it's telling me, hey, you're done reading this chunk, but the directory continues in whatever chunk is indicated here. So I go to where this tells me, I check the names again until I find the one I'm looking for. Then I read the size. It tells me how much data I need to read. And I know how much data I'm going to read from each pointer that I find. So I go to the first pointer, I read as much data as I possibly can. If I still need to read data, then I go to the list pointer. It will point me to another entry, somewhere else in the disk. It will have 63 pointers. So it's a list like that. And it tells me, I read enough from these 63 pointers. And if I still have more to read, then I go to the next list, which is the same structure, and I read the same thing. Each time reading 512 bytes of data. Okay, I feel like that makes sense. Kind of. Directory is a list of entries. Fixed to chunk size and the entry being 128 bytes. Okay. So a directory is a list of entries, fixed number of entries. If you need more than that, the last of those entries is going to point you to another place where you continue the same process. Simple. Once you find the entry that you're looking for, entries size read one chunk from the entry pointer. If that's not enough, follow the list pointer and read off read off the list pointers If that's still not enough, you got a fat ass file going on. Go to next list and read that. Okay, what about writing? What if I want to write? I follow down to the directory. A new file. When writing a new file, I follow down to the directory that I'm trying to read to. Find its end. Either a find the last entry with the attribute last. Make it not the last one. Add a new one. And if not enough space in current chunk, allocate a new one. So we don't know how to do that yet. But also when writing an existing file, find its tail. Do you write the whole file or do you just write to the end of it? When appending to an existing file, you find its tail. It shouldn't even be too difficult to do the math for that. To know exactly where you need to go. Whether here, here, or somewhere here. Until you find the end. Calling it cluster here, it should be chunk. Okay, when writing is going to be a little bit more complicated, but essentially you follow down to the directory that you want to go to. In that directory, you go through its entries until you find one that is marked with the attribute last. You unmark it as the last one because it's no longer the last one. You now want to go to the next one after that. If it's a pointer, you follow that pointer and you right there. Or if it's supposed to be a pointer anyway, you create a pointer. So allocating a new chunk and writing your entry there. If not, you're going to simply write to that entry. Say, okay, there's your file. And of course, you need to have the number of chunks and it's not ideal to do like a free list type of thing. For allocating new chunks. I don't love it. I don't love that idea. But it is a possibility. Okay, I feel like the logic for this is done. Likewise, when you're appending to an existing file, then you have to find the tail, which can be done through some simple math here and here, and here and here. Points you exactly where you're supposed to be, and you write, and you should know how much to write for. And whenever you need to, you allocate a new chunk and you write there as well, and you put it in the list. The problem now becomes how to allocate new chunks. And so I can just put up, like the way that I would do it if it was in RAM, is just point to the next free chunk and the free list chunk. So that this just tells you where the next empty chunk is. And you know, when you don't have anything written, it's simple. You just write to it. I could just follow this and it takes you to where that is and you just use it. If instead you can just use a list, a free list that's just pointers to, how do I explain this? Like, this is my one chunk, this is another chunk that I'm using, this is another chunk that I'm using, and this here is my header. Right, and it points to, at first, it points to the next chunk that's freed. So like, okay, you need to allocate something, you put it here at the end. But if this chunk becomes freed, it's no longer being used, then, and say that, let's make it a little bit more complicated. Also, this chunk is free. It's used, then it gets freed. Then you can just go from the header is going to point to this chunk. And you can use it. And it will point to the next chunk. I will tell you to use that. So you can reuse chunks like that. And to reuse it is to tell it, okay, I'm done. I'm going to use you now. You use it, and the pointer to that one becomes this. I don't love that idea, but it could work. Okay, there's an ad. So I probably should have waited for that to finish. But I'm kind of ending the stream soon, so I feel like there's probably a way to simplify what I just said. Because this one works for memory. And a lot of the times you have to follow the list because you don't know when, like if you have enough space in the freed chunk to put something new. But in this case, that's not necessarily the case. This damn dog. All right, we're done with the ad. I was thinking about how to allocate chunks, and I was thinking to just have a pointer to the next fully free chunk and a pointer to whichever chunks get freed, which themselves get replaced with a pointer to the next free chunk as well. At which point, can I just do one chunk, one pointer, I mean? That you just follow. Yeah, I should be able to choose one. So when I'm looking to allocate a chunk, I find this next free chunk pointer. It takes me to this chunk right here. This one takes me to this one. And this one takes me to 0. So I know that it's the last one. And in that case, then I'm done. And I found the last one. Then I change this one to 0. I get rid of that, and the chunk is allocated. None of this is efficient in the slightest, but it works, which is what we care about. It might just end up that this file system implementation just ends up being a RAM file system type of thing. It's going to start as a RAM file system type of thing. It might end up staying as a RAM file system type of thing, and then using a better, more efficient file system when it actually comes to it. But for the time being, this is fine. Wait, I didn't mean to delete that. Allocate, just throw powerful hardware at it. Who needs efficiency? Me. But, you know, step 1, build it. Step 2, improve it. We're at a point where actually we're putting some data here for a version number, but we're not using it. I can introduce breaking changes at any point. So let's take advantage of that. Hello, Factor. Welcome, Raiders. How you doing, guys? The pointer to that one will... Heyo. Thank you for the raid. Sad to say I was gonna end the stream soon, so I might just end up raiding someone else. Keep your coats, shoes, and hats on. We're gonna be hopping off to another stream soon after this one. And I'm gonna hop off as well because I'm gonna go have dinner after that. So don't get too comfortable. Raid equal 2 more hours, I'm sorry, but no. I haven't had dinner today. Or a proper lunch. So, or breakfast. Yeah. I've pretty much just eaten fruit. You could also try implementing virtual memory. I did, technically. I have the implementation of it. I moved to the main branch right now just to write this, although I'm not going to commit it. It's just a spec at this point with a stupid name that I'm going to change. But yeah, I might commit it to main. It doesn't really matter. Then after the stream, after dinner, I'm going to implement virtual memory. But I have it mostly working on my laptop. There's just like one thing I need to figure out, and then it's going to be working. So I will eventually. Okay. So already, what parts of this are inefficient? Reading, writing, allocating, everything. Everything is inefficient. Yeah, allocating with a free list on a fucking file system is stupid, but I don't know how else to do it. So I'm just, like I said, make it work first, make it good later. Take advantage of the fact that I can introduce breaking changes at any point with absolutely 0 consequences. The chunk list might not be super inefficient, but if you find a way to put them together, maybe it's going to be better, but I don't know. I don't know enough about file systems, so version 1 is just going to be a very naive implementation of a file system, and version 2 hopefully will improve on that. whatever. But okay, we have designed a file system. My network has gone down a little bit. It dropped 2,000 frames, but that's nothing compared to the ones that it didn't drop. So that's pretty cool. And like I said, yeah, it's starting to be the end of the stream. And by starting, I mean it is the end of the stream. But we are going to raid. Although, I'm not exactly going to raid and run. I'm going to be around, but I'm not going to be like super interactive because I'm going to figure out dinner. So, yeah, okay. I'll figure that out. I'm going to link to Twitch in case anyone on YouTube is interested in joining the raid. If not, barring any major issues with my internet, which hopefully won't happen, besides that 1 hour that I wasted with shitty internet, it's been fine today. And it's been fine every other day. It's just a small issue. It happened today and Monday, apparently. But yeah, I might start implementing this file system in RAM entirely. I'm not really interested in doing it in like actual file system just yet. Not much of a point to that. There's not much of a point to this in the first place, to be completely honest. Maybe I'll work on something else tomorrow and just leave the implementation spec for this one. But it would be nice to have a RAM FS. I don't know. There's just not a whole lot of use cases for a file system right now, besides what I already have, which is not using the system. So who cares about this system? If anything, I'm more interested in doing like the distributed file system that I am in doing this one. But yeah, forget all that. None of that is important. Maybe actually, yeah, instead of implementing this, I might just like refine it a little bit more before implementing it. Or I might just leave it as a RAM FS until it is time. But most likely I'm not interested in writing to a file until it's time to actually write to a file, which so far I haven't needed. And yeah, I'm not sure what I'm going to work on tomorrow. If it's going to be this or something new. I feel like something new might be a better use of my time. But that's going to be the end of today's stream. Tomorrow's stream is going to be at 3 p.m. CEST through 2 p.m. UTC. Is UTC the right word for it? UTC, yes. Universal Time. 2 p.m. UTC, 3 p.m. CET. You can translate to that time zone to your own. And again, not sure what I'm going to work on. Hopefully I'm going to have like virtual addresses actually working. Again, just kind of find that little pesky bug. That one, that's just one so close, so close. I'm like 1 bit away from it working. No, I don't know. I don't know what it is. But yeah, I got to figure out that bug and then hopefully it's going to be working. Don't know if I'm going to implement this in RAM or not. I don't really see a use case for it right now. So maybe I'll just leave it as like a header file, use it as an implementation spec for the time being. Not even committed to Git. Well, let's commit it to Git. What the hell not? Might as well. All right. With that, I'm going to end the stream on YouTube and look for a target on Twitch. So thank you so much, YouTube. I'll see you tomorrow.